In today's presentation, which is generic scale 1 presentation, chapter 2 diode, critical work 2 in semiconductor devices, presented to uh, Sir Faris bin Hamdani. Presentation by Muhammad Ishwan Shah bin Sabrini, 20 DEE 24 F1069. And Era Natasha binti Muhammad Yahya, 20 DE 24 F1059. And Terry Laveno anak Riang, 20 DE 24 F1069. The objective on this practical work is to able to construct the circuit on the bottom, which is half-wave rectifier, using multimeter to measure voltage and current in the circuit and trace the input and output waveform of half-wave rectifier circuit using oscilloscope. This is the circuit. We have AC power supply connected to diode, connected to LED, connected to resistor, and after that, this is the AC signal for V in, and this is a rectifier waveform for V out. Definition and formula. Peak voltage, or VP, is the maximum voltage in a waveform, the highest point ever reached by a waveform. V peak for the formula is V peak equal to V peak to peaks times 0.5. V peak equal to V RMS times square root 2, and V peak equal to V average times pi over 2. Root mean square voltage VRMS is a way to express an AC voltage in the term of DC voltage that produce the same amount of power. For a half-wave rectifier, the RMS voltage is lower than the peak voltage due to the absence of half the AC cycle. VRMS equal to VP over square root 2. Average DC voltage VAVG. It is an DC equivalent voltage by averaging the voltage output over one cycle. For the formula is V average equal to 2Vp over pi. Average current IAVG is the average amount of current that goes through the load resistor, or the average amount of an alternating current AC over a period of time. For the formula is IAVG equal to RL times VAVG.
So my name is Era Natasha. So today I want to explain about figure A. So here we can see the figure from 3.2 that have half wave rectifier with step down transformer. So here we can see how to connect it and how to do the circuit. So first of all, we need to connect the circuit such as at figure 3.2. After that, we need to choose the step down transformer on 12 and 0 volt. Using the oscilloscope, determine the input AC waveform at the point A to point B and DC output waveform at the point C and D. Also, we need to draw the input and output waveform and record the peak voltage. After that, we need to calculate the VRMS, V average, and I average. So after that, by using the analog multimeter, we need to measure the RMS voltage at the point A and B, at the point A to B, and record the reading. So after we do the same, we need to do the same thing on uh, point point C and D to get the average voltage. After that, we need to insert a multimeter in series with RL to measure I average. So here So here the result of the procedure A, we can see here that the volt per division for input point A to B is 4, VPP is 37.20 volt, and the VAC is 18.6. So we need to calculate it using the formula of VRMS is VP must need to we need to got the VP volt, after that over the square root. So we got the answer is 13.01 VRMS. So the measure value is the same value of the calculate value. So I pass my slide to my partner.
This is different in DC output. Voltage table 2.1 show the average voltage as 17.01 volt, considering the diode voltage drop, and table 2.2 does not especially mention average, but it is expected to be close the recorded AC voltage. And this operation of a half-wave rectifier convert alternating current AC to direct current DC by allowing only half of the AC circuit to pass while blocking the other half. Used in power supply as a simple rectification method. And this is conclusion. Output waveform will be analyzed using an oscilloscope and digital multimeter. For this, student will understand the function of a half-wave rectifier and exchange the lab skill. Okay, that's all.